Have you ever wondered how we get electricity to power everything we use in our daily lives? Well, electric generators play a huge role in providing us with electricity for our lights, phones, and many more electronic devices. Today, I'll be talking about the physics behind electric generators and introducing a generator project that I've developed. The main goals that I had for this project were to investigate the conversion of mechanical energy to electrical energy, as well as develop a greater understanding of the topic of electricity in physics. Before I start introducing my project, I would like to explain some of the physics relating to electric generators. Electric generators are based on the principle of electromagnetic induction. In 1831, British scientist Michael Faraday demonstrated that when a permanent magnet was pulled in and out of a coil of the wire, an electromotive force or voltage was induced. After some experiments, Faraday created a law stating that a current will be induced in a conductor, which is exposed to a changing magnetic field. This can also be modeled by the equation EMF is equal to the negative number of loops times the change of magnetic flux over the change in time. The negative sign accounts for Lenz's law, which states that the direction of the induced current will be opposite of the changing magnetic field that produces it. Through the law of electromagnetic induction, Faraday helped set up the template for the development of generators, motors, and transformers, as well as future series. Now that we know the basic physics concepts behind generators, let's look at the generator project I made. My generator uses a DC motor, which is a motor that runs on direct current, but it can also be reversed and used as a DC generator. A belt is attached to the motor shaft and around the bicycle wheel. When the bicycle wheel is spun, the belt spins the motor shaft. The copper wire on the shaft moves through a changing magnetic field created by the permanent magnets. This induces an AC current in the wire, which is then converted to DC through a commutator. A commutator does this by reversing the current produced by the coils every half turn, therefore only allowing current to flow in one way. The direct current can then go and power the small light bulb. I originally wanted to create a generator that uses actual copper wire and magnets to generate voltage. I was able to create a prototype which involved spinning magnets passing by a copper coil. After many tests, this generator was unable to produce a sufficient voltage. Some reasons I think might have caused this could have been a lack of magnet strength, inadequate copper wire, or some other unforeseen factors. Therefore, I chose to create the motor design because of its efficiency and reliability. When I spin the large bicycle wheel, the motor shaft can turn many times, creating a high voltage. I can calculate that approximately 60 turns of the motor shaft result from one turn of the bicycle wheel, using the radius of both. Since the equation for Faraday's law is divided by the change in time, a faster spinning shaft moves the copper wire across the magnetic field faster, therefore higher voltage is created. Something else I added to my design is a bamboo handle that I can use to spin the bicycle wheel. This handle allowed me to spin much faster than using my hand, allowing me to bring my voltage from barely 1 volt to almost 3 volts. If I were to improve my generator project, I would do the following things. First, I will make a better handle for spinning the bicycle wheel. This is because the current handle I'm using often shifts positions under pressure and lacks an ideal grip. To fix this, I could make a handle crank, which allows for better grip and efficient turning. Another improvement I could make is using a better belt that has more traction. This is because the current belt tends to fold and bend at high spinning speed. To fix this, I could use a rubber band for this belt. One more thing, if I were to do this experiment again, I would probably try making a generator using actual copper wire and magnets instead of using the motor. In conclusion, this project demonstrated how mechanical energy can be converted into electrical energy using electromagnetic induction. I was able to learn more about concepts in physics and electricity. Even though this project was not fully successful, It demonstrated Faraday's law clearly and helped connect many physics concepts into a working system.